Alright, so here it says SAT scores and the percent taking the SAT. So again, these are data points from all 50 states in Washington, D.C. And it shows along one axis the percentage of the students in that state that take the SAT exam. And that ranges anywhere from 0 up to 90%. Okay, so some states, 0% of the students take SATs. Maybe most of them take ACTs or whatever, or very few students take the SAT, or a lot of them are taking the SAT. And on the other axis, we've got the mean quantitative score. So those range anywhere from 450 to 625. Okay, and we see definitely some kind of trend. Okay, we see a part A asks, is it showing an increasing or decreasing trend? Okay, and we definitely see a decreasing or negative trend, which means, and it says explain what this means in the context of the data. And so what this means is that in general, states where a high percentage of the students are taking the exam, states where a high percentage of the students take the SAT, the average score is low. Average score is lower than the states where very few students take the SAT. And it says, do the points seem to follow a straight line or a curve? Okay, and so if you ask me, it looks like there's a heavy, dense group over here, and it seems like a curve is more appropriate. Okay, so part B, I would say a slight curve. Okay, and so the last part says, is it appropriate to find correlation for this data? Why or why not? Okay, and C would be probably not, because the relationship is curved. Because of the curve. And again, correlation only makes sense to do if you have a straight line relationship. Okay? Yes, you can calculate the correlation. Correlation does exist even for curved relationships, but it only really makes sense when it's a straight line.